So good morning, children. Today's our class topic is continuation of the same chapter, Fraunhofer diffraction due to single slit. Okay, so we already started this topic, so we already complete the diagram also. The Fraunhofer diffraction due to single slit. You can to see here the slit is given here, that is AB, and plain wavefront is entering to the slit. Plain wavefront, you know what is a wavefront, and different types of wavefront also we have. So plain wavefront is entering to the slit, that AB is the slit, and the wavefront will be entering here, and the wavefront is happening touching to the edges. It will be happen bending, so that's the reason that's will experience diffraction. So you can to see here, without refraction the dotted line is passing through from the C, and the dotted line is passing through the A and the B. These points are joined together. A common point is O, that is called the central maxima. Okay, central maxima. The diffraction pattern, the O is shown to the central maxima, and maybe the diffraction will be happen. It will be start to bend like that, start to bend, and joining another point, that is P1. This P1 is x distance from the O is contained central maxima, P1 and P1 dash is central minima, P2 and P2 dash is central maxima. Like that we have already studied the diffraction pattern. Okay, so the distance between the screen and the lens, that is called as focal length. Distance between this slit and the screen, that is called as D. And the A means the distance between these two slit points A. This A is also called as lambda, slit width lambda. The dotted lines are denoted by secondary wavelet. We already know every point of the wavefront is contained secondary wavelet by the Haugen principle. What is the Haugen principle? The locus of the points contain secondary wavelet. So all the points of the wavefront contain secondary wavelet. The dotted line is denoted by secondary wavelet, and slit width A, that is also called as lambda. You can to see here a perpendicular line is drawn from A. That line is joined the point N. This BN is our path difference. How much it will be diffracted depends on the angle theta. Theta angle is help to diffracted. So what we want to find out? We want to find out the intensity of the point O and P1. What are the intensities in the point of O and P1 that we want to find out? So at the point O, we get bright central image because secondary wavelet from parallel to equivalent distance from C. The point O contains central maxima, and brightness is maximum in the point O because the point O equal distance from the point A and B. So that's the reason secondary wavelet maximum brighter in the point O. Then above and below the point O, there is to attend maxima and minima. You can to see the above and below the point O, secondary minima, secondary maxima, like that alternatively secondary minima and maxima will be formed. Intensity of the alternate maxima decreases and alternate minima goes to 0. We already know one by one the alternate maxima will be decreases and minima is come to 0. Then AB is the wavefront. We already know AB. Here is AB. This is AB. That AB is our wavefront, AB. And BN is the path difference. And path difference, I am already explaining you, BN is the path difference. We should consider the triangle BNA. You can to see here the diagram. Where is BNA? Triangle BNA. This is a 90 degree. This is theta. So we should consider sine theta. What is sine theta? Opposite side by hypotenuse. So opposite side is BN, hypotenuse is AB. So sine theta equal to BN by AB. We should get like that. So sine theta equal to BN by AB. So what is BN? BN means AB sine theta. BN means AB sine theta. So we should consider BN. BN means path difference. Path difference equal to AB sine theta. What is A? AB. AB means A, slit width. So A sine theta. So we should get it out. Bn equal to A sine theta. We already studied in the previous class path phase difference equal to 2 pi by lambda into path difference. Similarly, phase difference का symbol है phi. Phi equal to 2 pi by lambda into Bn. What is Bn? Path difference. What is the expression of Bn? A sine theta n. So phase difference phi equal to 2 pi by lambda dot A sine theta n. Okay. So this is our first expression for that. So now AB is divided into two parts. We already know AB divided A to C and C to B like that. So total length distance of AB is A or lambda. So division के बाद कैसे हो जाएगा? AC और CB equal to lambda by 2. Half of that lambda by 2. Then we should going on the derivation of secondary minima and secondary maxima. First, intensity for minimum intensity at the point P1 or secondary minima. In the case of secondary minima, you can to see like that. Path difference equal to even multiple of lambda by 2 of the diffraction. Why we should consider even multiple? Because in the case of 1, 2, 4, 6 like that the minimum will be getting. So even multiple of lambda by 2. Even multiple of lambda by 2. So how we should write? Path difference is Bn. Bn equal to A sine theta n. So this is the path difference Bn. Bn equal to A sine theta n. So A sine theta n equal to even multiple of lambda by 2. How to write the even number? 2n. 2n lambda by 2. Okay. So this is the common expression of the secondary minima. So even multiple 2n lambda by 2. So we should get sine theta n. A will be come to this side. 2n lambda by 2a. 2n lambda divided by 2a. Maybe the theta value is very small. Sine theta is come to theta. So we can write it as theta n equal to 2n lambda divided by 2a. The 2 will be cancelled. So theta n equal to n lambda by a. What is the n? Plus or minus 1, plus or minus 2, plus or minus 3 like that. So what is the meaning is that in the case of secondary minima, common expression of the secondary minima is Bn, path difference equal to even multiple of the diffraction. So path difference is A sine theta n. Even multiple means 2n lambda by 2. So sine theta equal to 2n lambda divided by 2a. Theta will be very small, so sine theta will be very, very small. So that's the reason theta n equal to 2n lambda divided by 2a. The next is in the second case, the maximum intensity of the secondary maxima. Same condition, path difference equal to, in the previous case even multiple, in this case odd multiple into lambda by 2. Then how to write the expression? Bn equal to A sine theta n equal to, how to write the odd multiple? 2n plus 1 lambda by 2. 2n plus 1 lambda by 2. So we should get the arrangement. Sine theta n equal to 2n plus 1 lambda by, this a will become that side, 2a. What is this n? Plus or minus 1, plus or minus 2 like that. So maybe theta is very small, sine theta equal to theta. So theta n equal to 2n plus 1 lambda divided by 2a. So we should get the secondary minimum and secondary maximum general expression. So from this expression we can understand that as obliquity matlab deviation increases, intensity decreases. Okay, deviation increases means intensity decrease ho jayega. So bending increases, intensity decreases. That is the meaning. Okay, then we should going on the next point of the chapter. Width of the central maximum. Central maximum ka width kitna hai? The width of the central maximum is the distance between first secondary minimum on either side of the central bright. You can to see this is the central bright. Central bright के एकदम पास में कौन है? Secondary minima. So this is also secondary minima. This is also secondary minima. So distance between the secondary minima, that is called as width of the central maxima. Clear everyone? So what is the width of the central maxima? Distance between the secondary minima, that is called as width of the secondary maxima. So we should consider here for a secondary minima, what is expression a sine theta equal to n lambda, we already know. So what is sine theta? Lambda by a. For n equal to 1 hai, so sine theta equal to lambda by a. We should consider the triangle OPC. We can to write it as sine theta equal to y by d. What is y? You can to see here the half of the width of the central maxima, that is called as y. So y by d. What is the d? Total distance. So sine theta equal to y by d. In this case, sine theta equal to lambda by a. So I can to replace these two. Y by d equal to lambda by a. So what is y? Lambda d by a. What is the y? Half width of the central maxima. So पूरा width कितना है? इधर to इधर तक y है. So total means 2y. So 2y equal to 2 lambda d by a. Clear everyone? So what is a? Slit width. So a decreases, width increases. What is this 2y width? Which width? Slit width. Okay. So a width of central maxima increases when the width of central maxima increase करूँगा slit का width reduce होने के बाद. Then angular width of the central maxima, that is called as 2 theta. So a sine theta equal to lambda. So sine theta equal to lambda by a. So for small angles theta equal to lambda by a. So angular width 2 theta equal to 2 lambda by a. We have to write it as the angular width 2 theta equal to 2 lambda by a. The last topic of the chapter, difference between interference and diffraction. What is interference? Interference, intensity of maximums are same. Interference ka intensity maximums are same. But in the case of diffraction, intensity of maximas goes on decreases. Just now we have to tell it as maxima intensity is always decreases in the case of diffraction. But in the case of intensity, maximum intensity is always same. For maximum, intensity maximum, path difference ka expression is n lambda. Intensity is minimum, path difference expression is 2n minus 1 lambda by 2. But in the case of diffraction, path difference is maximum, diffraction is maximum, path difference is 2n plus 1 lambda by 2. And diffraction is minimum, path difference is n lambda, just opposite. Am I right? Yes, next. Interference is due to the superposition of light wave from two sources. What is the interference? Two light sources का combination है, superposition है. What is diffraction? This is due to superposition of secondary wavelets from one source. Next, coherent sources are required for the interference. Diffraction is also happening in the coherent sources, but it's not a compulsory. Okay, so this much for today's topic. So hear it properly 1 or 2 times, and you have any doubt you can ask me. I have a clash today. I can't adjust today. That's why I will take the recorded video for you. Next day onwards you have a normal classes. Okay, normal online classes. Thank you.